Okay, good morning, everyone. We are starting. We want to look at question 3 today, but maybe before we look at question 3, let me just recap. Last time we met, we did question 2. We explained, not explained. We just let me see. Oh, there was question 1. We didn't do much on question 1. We'll come back to it. Let me start with this. Sorry to take you back, but I think this will be important. There is this part. I know you did part of this. We are going to do it again. I just want to read 1.7 before we move to question 3. Guys, are you there? Can you hear me?
Yes, I can hear you.
Yes.
Okay, great. Great. So let's start. I just want to go back to question 1.7 and look at 1.7.3 before we move on to our question 3. Let me read question 1.7. A researcher wants to set up a regression equation where y is a function of x. Evaluate the researcher's options given the following scenarios. I'm skipping 1, I'm skipping 2, I'm going straight to 3. This researcher, you want to set up a regression equation where y is a function of x. If you are faced with this scenario, the encircled scenario, what are you gonna do? Will you proceed with trying to come up with a model or not? I'm asking a question so that I'll answer it. Don't answer it. So if you're faced with a scenario like this, y, it's a variable, that's the dependent variable. X, it's an independent variable. And we are seeing that we are also given the error term there, right? But there's something, let me maybe use blue here. I'm seeing that my y is I0. I'm seeing that my x is I1. And we are told that our error term is I0. Right? What is this?
Sorry.
Yes.
Sorry to interrupt you. You said a y is I0. It's I1, right?
Oh, it's I1. Sorry for that. It's I1. Thanks. So what we are given here is y. Y is I1, x is I1, but the error term is I0. What's this I1, I0? Here we are simply saying, if you look at y here, it's a non-stationary variable. It will only become stationary after differencing once. That's why we are saying it's an I1 variable. The order of integration is 1. Then if you look at x, the order of integration is 1. In other words, we are saying it is non-stationary in levels. It can only, or it is stationary after differencing once. Then if you look at the error term here, we are saying the error term we are having is stationary in levels. If you run a regression, in other words, if you run a regression of y on x, the error term, if you look at the error term or the residuals that you get will be of I0. This is very important. But I just want you to try and remember what you you did with David, right? We are going to be using it today. So we are going to be talking of the order of integration. We are also going to be talking of residuals. They are very important. And I remember maybe it was your second class, or was it first or second class? David taught us a lot about spurious regressions. Like you run a regression, but your results are meaningless. So if results are meaningless, you would have wasted your time in running regressions. So to guard against that, I mean wasting time, you need to be checking for things like co-integration, stationarity, error correction model, and see if our model at the end of the day will be a good model or not. So today, let me go straight to today's work. I want us to look at question number 3. Remember, we're going to be using, sorry? I don't think it's a question. And remember to always mute. You unmute when you want to say something. Thank you. Let's go to question 3. Let's go to question 3. Where is it? Here. Yes, let's push.
So,
Yes, it's a question. Oh, no.
all right, sorry to take you back.
Yes.
On that error term that is saying I0, does it play any significant role on our model when it says I0?
Yes, it plays a very important role. You will see soon. It plays a very important role when residuals are integrated of order 0. It will play a significant role. Can you please allow me to proceed, and I'll explain it later. Is it fine?
Okay.
Sure. Now I'm reading question 3. We need to push here. In this question, you must estimate a time series model for value added, which is VAT collections for South Africa. So our dependent variable is VAT collections, right? You are provided with the following data. VAT is the value added tax revenue. It's in nominal terms. HCE, it's final consumption expenditure by household, it's in nominal terms. HYD is disposable income of households, and it's in nominal terms. M3, it's our money supply, it's in nominal terms. LAB is the nominal labor costs in the non-agric sectors. We're also given inflation as well as the consumer price index. 3.1 we did last time. We managed to provide a description of the data. Maybe, let me do this. Share screen. Are you seeing the Word document that I'm sharing now?
Yes.
Oh, great, great, great. So this was 3.1. They wanted us to provide a description of the data. We did that. They wanted us to calculate and provide a graph of real value added tax for that period. This is our calculation. This is our graph. We also discussed the trends that we observed in VAT collection before and after 2008. This is what we are having. Right? Now we are moving to 3.3. 3.3. 3.3, let's read from the assignment here. 3.3, they are saying test, we're going to do it quickly because we now know how to test for stationarity. Test the real, let me underline the important stuff here. Test the real VAT and inflation variables for stationarity. Provide your results in the table below. Please add rows where necessary. I don't know if we are given the table or not. Let me quickly check. Yes, they are saying there's a table below. Oh yes, there's a table below. So they are saying using this, we can add more rows if necessary, right? This is what we have. This is what we are given. And let me say it from the word go. It's advisable to test for stationarity for all the variables you are given or you are having. But let's try to stick to the question. They just want us to test the real variable and inflation variables for stationarity. Only these two. Let's not waste our time trying to test for M3, for HYD, and all those other ones. In this case, they just want us to test for stationarity for only two variables. Are we together there? So don't waste time here and adding more variables. You will not be penalized for that, but you won't be getting any marks for that, right? So we're going to test for VAT and inflation. So where is my, is it a question? No. Let me try to put my e-views here next to the Word document we are having. So here's the Word document. Here's the Word document. Let's have our e-views, or maybe I should start opening it. You know what? Last week when we were doing this, I saved my stuff. Where is my stuff? It's ECS. Okay, it's here. This is what I have. Yes, this is where I'm saving my stuff for 2022. So we opened the data, we did all those other things. So I have my assignment 1 here saved. It's a work file. It's already in e-views. I want to like start from scratch. I have it already. It was saved last week. I'm just opening it. This is what I have. This is my e-views. I hope you are seeing it. Are you seeing it, guys? The e-views?
Yes.
Yes.
From last time. So maybe today, let me delete some stuff that I did so that, yeah, so this is what I'm having. So the question is saying, we are starting now. The question is saying, test the real value-added tax and inflation variables for stationarity. Provide your results in the table below. Please add rows where necessary. It's for 6 marks. So if you look here, if you take a closer look, you'll see that we want to test for real VAT as well as inflation. But the good thing, like I said last time, your lecturers, they like you. This is just a hint. They're telling you that VAT should be logged and you should also make it real. Oh, guys, remember to mute when you are not saying anything. You only unmute when you have something to say. Okay, sorry for that. So let's push. You are given a hint your VAT should be real, it should be in real terms, but there's inflation. Inflation it's not even logged. It's a hint for you. You're not going to log it. What if this table was not there? They just created the table, or sometimes they do this. Sometimes they can just say, test the real value added tax and inflation variables for stationarity. And you know what? In here, like in this column, you have nothing like this. So it means you are the one who should go and write some stuff. There's no like a hint, you see. So what I usually do when before I start testing for stationarity, I'll go to my VAT, obvious VAT, where is it? Here, I open my VAT and sorry, and I go to the graph. Please mute when you are not saying anything. You only unmute when. Okay. So if I go there, I can see that my VAT, it's positive. 0 is here. I'm saying here, maybe I'm not seeing 0 is here. And I can see that VAT is above 0, like the values. So this one is positive. I'm going to log this one. I'm going to make it real and then log it. Then let me check my inflation. Before I do anything, I have to check also inflation. If I open inflation variable here, I go to view, graph. I go to view, graph. Come on. Then I click on OK. I can see here. I can see that 0 is here, but if you look at inflation, somewhere here, I think it's negative. Can you see it's negative 1.6? Can you see that?
Yes.
Even here, negative 1.4. So this one, we are not going to log it. Because you can't log this variable. It means in some years, it's having negative numbers. And you don't have to log negative. You can't log a negative number. It means if you log this one and in that year, in the year where it's negative, you won't be having any number there. It will be undefined, right? So we don't log this one. You can check using these graphs. It's fine. So let me quickly start with real, making VAT real. How do we do it? We go to generate. We want to have our RVAT. RVAT is, we did this last time, is equal to VAT, which is nominal VAT, divided by CPI times 100, right? That's the RVAT. There is a new variable, right? Always remember to save your stuff, right? That's the RVAT I'm having there. Now, I want to log the VAT. I go to generate. I want to have LRVAT. What is this LRVAT? This LRVAT is equal to the log of RVAT. We are telling the system, all right? We know we need to have a new variable called LRVAT. What is LRVAT? Is the log of RVAT. We tell the system, I click there, we have a new variable there. Always remember to constantly save your work, right? So I have LRVAT. Let's now test for stationarity, because if you look here, this is what we are looking for. It's not just RVAT, but it's the logged one. And we now have this logged RVAT. That's what we want to use, right? So let's quickly do it. We are testing for stationarity. I know you now know, so let me try to be a bit fast here. I will double click on LRVAT. You know, because of pressure, sometimes we can make mistakes. Quickly check if you're actually on the right variable. That's it. That's the LRVAT. Quickly check. Because of pressure, you might miss some stuff, right? We go to view. We go to unit root test. We are testing this in level. Can you see that? We are in level. There's no D here. We are in level, right? Let's test this in level. We are starting with, or maybe let me fix my table here. Just a second. I don't want to confuse myself. I want to have trend and intercept in one line. Like this. Let me try to fix my table so that we won't confuse ourselves. Let me also save it. Okay, so I want to start with trend and intercept. So I should click here on trend and intercept. We are still testing this in level. This we now know, click OK. Okay, right? So I come here, this is my ADF, I copy it. I will paste my ADF here, right? What is the leg length? I'm seeing is 7 there. If I'm too fast, tell me. The leg length is 7 here. So I have to put the legs 7 here. Now, is it stationary or not? Is it stationary or not? What do we use? We use, let's use the rule of thumb. If ADF, the augmented Dick Fuller test statistic, is less than the test crit. I'm talking about this, I'm referring to this. The test critical value, let me just say test crit. If it's less than the test crit, conclude that the variable is stationary. You conclude that the variable is stationary. So we're looking at the ADF here. If the ADF is less than the test crit, conclude that the variable is stationary, right? So let's quickly do it. How do we do it here? We're seeing that, where am I? I'm here. This is the ADF. Let's compare it with the 3 test critical values. At 10%, -1 is greater than this. Can you see that? -1 is greater than -3. -1 is greater than -4. So in this case, no star. In other words, we are saying it's not stationary. Are we together there?
Yes.
Yes.
Sharp. Let's move on. Let's move on. So you now know this part. Let's move on. Let's move to intercept. You just go to view. You go to unit root test. You click on intercept. You click OK. You look at this one. If you look at this, let me copy it and paste it here before we comment. And paste it here. Oh my God. Hello, are you there?
Yes.
There was something happened here.
Yes, brother.
Yes. Yeah. It's not stationary. No stars.
Okay. What is our leg length is 7.
7.
And look, 0. If you look at this one, -0 is greater than all these 3. So no star, not stationary. We move on to the last one where we test none here, right? If you look at none, it's +2. +2 is greater than all the 3. The 3 are negative. So it's not stationary, no star. No star, right? The leg length is 7. I'm also saving my work here. Now, because I want, in the exam, you don't have time. I know the table is showing me that I should move to inflation, but it will delay me. Why can't I just move to the, oh, sorry, there's a mistake here. Let me correct. In this bracket, this should be L. There. It's still locked. So I'm saying here, let me not move to inflation now. It will delay me. Let me just go there to the differenced one, right? So that I will not close my e-views. I'll just finish with VAT, then I'll go back to INF. Are we together there?
Yes.
Right. So now I'm still on logged RVAT, unit root test. Now is the first difference, starting with trend and intercept. I click OK. What is the leg length? I can see that the leg
6.
length is 6, right? What about the ADF? It's this one. I'm copying it
3 stars.
and I'm pasting there. Okay. How many stars? If the ADF is less than the test critical put stars, let's do it slowly on this one. Then going forward will be quick. If you look at minus 5.88, this one, and you compare it with this, the first one, you can see that minus 5 is smaller than minus 3. Obvious. Minus 5 is less than minus 3. So that's our first star. Comparing with the next one, minus 5 is smaller than minus 3. So another star. Then lastly, minus 5 is less than minus 4. So that's the third star. If we are saying 3 stars, what we are saying, this one is stationary at what? We have a hint here. We have a legend, we have a key here. You can see the key here, statistically significant at, if it's 10%, put 1 star. If it's 5%, put 2 stars. If it's at 1%, put 3 stars. And I think you can see that the moment it's significant at 1%, it will be also significant at 5, automatically also at 10. So the moment you see that it's significant 1%, don't waste time. Know that it's 3 stars. It will be significant even on the other one. I am saying here, for example, I'm not starting from below there. I'm just starting from here. I want to compare my ADF with this one. I'm starting with at 1%. The moment I compare -5 and -4 and see that -5 is less than this, I'll put 3 stars. I'll know there's no need for me to check on these ones because automatically it will be less than these ones. So in this case, we need to put 3 stars. So I'll come in front of our figure here. I'll put 1, 2, 3 stars, right? Let's move on. Are we together? Yes, we are.
Yeah.
Let's move on. Now I'm going to the intercept. We are still in first difference. Now we include intercept. We're including intercept. We are seeing that it's -5.9 something something. I have to put it here, right?
3 stars. And
it's less than all the 3, so 3 stars. And the leg
6.
It's 6. Great. Lastly, to include in our test equation, none. Again, -5 is less than all those ones. So 3 stars.
3 stars.
So I'm pasting it here. Right? I put my 3 stars. So if you make a mistake and you are putting 2 stars there, you will not get all the marks because you are lying to us. You are saying it is significant at 5%, which is 2 stars. Yet it's significant at 1%. So make sure that you don't make mistakes here. If you put 2 stars, your answer becomes wrong. So we need to have our 3 stars there. And the leg length is 6. Now we're done with this one. We move on to our inflation. We move on to our inflation. Where is inflation? It's here. Are we going to log it? No. Why? Because it's containing some negative numbers somewhere, right? We're fine with this. This is the graph that we once opened. So to go back to where we were, we just click on sheet here, right? This is what we have. We want to test for stationarity. Just go to view. You go to unit root test. You are in level. We start with trend and intercept. I hope you are seeing where I am. I am here. I'm starting with trend and intercept, right? So we click OK. I click here, it's -5. And can you see that this -5 is less than all these ones? So how many stars there? Others, how many stars?
3 stars. 3 stars.
3 stars. Oh, great. 1, 2, 3. And the leg length?
0.
We move to The next one, which is intercept. How many stars?
3.
3.
3 stars.
3 stars. Paste there.
The leg length
1,
0.
2, 3. Leg length. Leg number of
Zero.
legs 0.
0.
What if we put none? How many stars? Okay, let's start with the leg length. How many? What is the leg length?
4.
4.
Let me paste it there. How many stars?
1.
It's 2 stars. 2
Three
stars.
stars.
1 star.
1 star.
It's 1.
I'm hearing 1 and others are saying 2. Should we vote?
1.
It's
Me, I'm
1
I'm
star.
going for two
It's
stars.
1.
1.
2 is 2.
2 stars. Me, I'm 2 stars.
No, 3 stars.
Okay, it's 2. It's 2
let-
stars.
Okay, let me send, great. Let me send the ballot paper so that we vote.
Ilonga is voting for 2 stars.
Okay, it's fine. Let's do it together then and see why are we saying 2 stars. Myself, I don't know. So let's do it together. Okay.
It's 1 actually.
Let's start with this. The first thing, I wanted to click somewhere there, like outside like this.
It's 1.
Okay, can you see that here we find all these 4, they are negative. Can you see that? It's fine there, eh?
Yes.
Let's move
Yes.
on to the first digit. Can you see that if you compare -1 and -2, -1 obvious it's greater than -2. So this can never be stationary at 1% level of significance. So this one is out. Are we together
1
there?
star. 1 star.
Yes.
Right? Okay. Then if you compare -1, here there's -1, there's -1. So we are still fine. For we move on to the next digit after the comma. But remember, they are negatives. They are negatives. So it's like I have -8 here compared to -9. Which one is bigger?
8.
-8.
Negative 9.
Sorry? Which one is bigger, -9 or -8?
Negative
8.
8.
Negative 8 is bigger.
Yeah, because these are negative numbers. If we're talking of positive numbers, 9 is greater than 8 when we're talking of positive numbers. When we're talking of negative numbers, -8 is greater than -9. So in this case, -8 is greater than -9.
Laba basemperiod laba ukuthi benze kind evali ngoba udriver yabatshela ukuthi no udriver sikahambile, we filled up somewhere with cash.
Sorry?
No, that one is for
I think he's on a phone call.
Yeah.
Oh, I thought maybe they're talking of money. I want money. Ish. Okay, so let's push here. We are saying we are comparing -8 and -9. -8 is greater than -9. So this one is gonna. Are we together?
Yes.
Yes.
For comparing -8 and -6, -8 is less than -6. So only
That
1
one.
star.
Only 1 star. Sorry. Yeah.
so there's no need to go for elections here. Okay, great. Are we all together there?
Yeah.
Yes.
Okay. So in this case, guys, like I said last time, you can live here and say, my inflation is of order, is stationary in levels, but could be stationary after difference in ones. But you know what I always like is to move on and try to difference it and see how it will behave and have a conclusive result. Is it stationary in level or after difference in ones? The moment I'm seeing this one having 1 star here, having 1 star here, in other words, it's significant at 10% level, I'm forced to move to this one to difference it. Are we together there? Okay, let me remove, let me say it again. This is coming from my head. Let's say after doing our stuff, please listen, guys. Here, I'm seeing it's having 2 stars. Here, it's let's say it's not this one. Let's say you are getting something like this. Is there need for you to move and try to test it after differencing once, or we conclude that it's stationary in level?
We conclude that it's stationary at level.
We'll conclude that it's stationary in level because at least it's stationary at 5% level of significance. We would rather use 5% and 1%. This is what we want. The 10%, it could be, there could be a need for us to move to the next level. Are we together? To difference it once or twice. So if we're having, if all these 3 were having 3 stars, 2 stars, 2 stars, 2 stars, or maybe this one having, let me put it here, or maybe this one having 3, this one having 3, it was still fine. We're not gonna move and difference it once. We're gonna conclude that it's stationary in level. But in this case, look, the last one is having 1 star. So in this case, we have to move and difference it once. Are we together there? Let's move on. Okay, I'm going to difference it once. Unit root test, first difference, trend and intercept. We click OK. How many stars?
3.
3.
We all agree it's 3 stars, right?
3.
And the leg length is 3. Moving to unit root test, include intercept. How many stars?
3 stars.
3 stars. Right? 1, 2, 3. And the leg length?
3.
What about on
It's
none?
3.
Thank you. None. How many stars?
3.
Oh, great. Now we can conclude that it's stationary after differencing once at 1% level of significance. So we're done with 3.3. Is it what you get? I thought I gave you this as a homework. I'm not sure. I can't remember now. Maybe for those ones who tried at home, did you get something like this?
Yes, so I got all the same values.
So it means so it means you are using the same data, right? Great.
Correct.
Yes, great. Oh, so it's fine if you are also getting something like this. Now moving to the next part, which is 3.4. Let me read it and try to explain. I think you can mute for now, because I want to explain some stuff before we do 3.4. Okay. We are moving to 3.4. I want to explain something here. Can you please listen and listen good? Because I want you to get something here. It will be easy for us to move forward and try to understand the ECM if we can understand what we want to do here. Okay, I should know your names, guys. You know what? I should also know your names. Oh, there's Walisa, Diana, Evelyn. Okay. So listen, guys. What are we trying to do? We don't just want to go to views, copy stuff, pasting there. What is it that we're trying to do here? Remember, we want to come up with a good model at the end of the day. A model that can help us make some forecasts, right? What is this model all about? The model is all about VAT collections. It's about value-added tax collections. What influences VAT collections? We are told here that there are so many things that can influence VAT. Final consumption expenditure can influence VAT. disposable income can influence VAT, money supply can influence VAT, nominal labor costs can influence VAT, inflation can influence VAT. How? On the how part, you need to turn to economic theory, because before you even came up with these variables, these independent variables, you had consulted economic theory. It should make sense. We don't want people who come here, imagine we are doing something to do with VAT collections here. VAT collections here. Then I add another variable here. I say the price of, because I like farming, the price of cows. Can the price of cows influence VAT collection? What do you think?
Yes, it can.
Okay. What if I say another variable? Maybe I say what can influence VAT? Then I just say climate change. Yes, let's say climate change. Or someone can say number of medical doctors in the economy. Can it affect VAT? How? So it's economic theory that should help you in coming up with your variables. It should make economic sense. It should make economic sense. So sometimes you see that we are putting a variable there, but it's not making sense. This cannot affect this. I remember David teaching you guys spurious regressions. He gave an example of, I know he's from Cape Town. He gave an example of something to do with summer season in Cape Town. And he said it's in summer, and you look at the maybe sales of sunglasses versus sales of ice creams. You see that maybe the sales of ice creams is increasing in summer, as well as the sale of sunglasses is increasing in summer. But if you want to regress sales of ice cream on sales of sunglasses, it will not make sense. Yes, they are moving in the same direction. The sales of ice creams are increasing. Yes, the sales of sunglasses are increasing. But is there any relationship? You can see that as this one is increasing, this one is also increasing. But is it making sense? If you regress one on the other, you might get spurious regressions. He was talking about that, right? So we want to guard against this. We need to have pre-tests. Let's not rush and finish the model without doing some tests. So now we are moving to co-integration. We want to see if where are we? 3.4, yes. We want to test for co-integration between variables here. Is there any relationship? Is there any long-run relationship between our variables? And maybe to ask a question that I'll answer myself, I'm asking a question now. In econometrics, what is long-run period? If someone is talking about the long-run period, what is it all about? Please don't say it's a period whereby all inputs are variable. We are saying in econometrics, when we're talking about the short run, what are we talking about? When we're talking about the long run, what are we talking about? Because right now on question 3.4, sorry, they want us to test for co-integration. But if you go to 3.41, Let me read it. They are saying, hey, because we are online, let me check if people are there. Can you still hear me?
Yeah.
Yes.
Okay, great.
Yes.
I'm on 3.41. Let me read it. Estimate the following long-run co-integration equation. Look here. They're saying estimate the following long-run co-integration equation. So, you know, when we are in econometrics, when we're talking of long-run period, it actually implies that variables have converged upon some long-term values and they are no longer changing. What am I saying? Let's say you are talking about y. Y in period 1 is 10. In period 2 is 12. In period 3 is 15, maybe it's GDP. Maybe in period 4 is 27. Or maybe in period 5, it's on 30. In period 6, it's on 31. Period, sorry. Next period, it's on 31. Another period, it's on 31. Moving forward, it's on 31, right? The moment you see this happening, like this part, you can safely say, you know what? This variable is no longer changing. It has converged upon some long-term values. We can actually say we are now in the long run. Are we together? But when it's changing like this, here there's a change of 2. Can you see that? Here there's a change of what? Here there's a change of what?
Of 3.
Here there's another change. My math is bad. So you know there's a change. Here there's another change, right? Can you see that? But
Yes.
from here to this one, please listen good. The change is equal to what? 0, there's no change there. Can you see that? Even here, there's no change. The moment you see this happening, where the change is 0, you should know that you are now in the long run, right? Are we together there?
Yes.
So what we want to estimate here is the long run co-integration equation. We want to see, is there any relationship between variables in the long run? These variables we are having here, do they have any relationship? But we're looking at when we are in equilibrium. In other words, we are now in equilibrium. When we are now in equilibrium, is there a relationship? You shall see sometimes they just say, estimate the long run equilibrium equation. It's this one, the long run co-integration equation. Is there any relationship in the long run? That's your question. We are starting with the long run. We want them to converge to, I think in some books you have read of steady states. When you're in the equilibrium, you are in the steady state. Is there a relationship when you're in the long run? But I know you have a question to say, why are we just concerned with the long run here? What about this period? Let me change the color. What about in this period? Which color should we use? Maybe green. What about in this period? Because from what I'm seeing here, it's like up to here, this is the short run, right? And if you look at this one, this is the long run. So we are starting by estimating this long run equilibrium relationship, right? Then, what about the short run? When I'm talking about the short run, where there are these changes, these are differences, these are like difference equations. We will be talking about the ECM. I'll talk about it. You shall see when we're estimating our ECM our variables are differenced. Our variables are differenced when I'm talking about the ECM, right? But when you're talking about the long run equation, variables are in levels. They are not differenced. That's why here, there's no D here. There's no D here. There's no D here, because we are talking about the long run. In the long run, variables are estimated in levels. In the short run, variables are estimated when they are in differences. Are we together there?
Yes.
Yes.
Okay. So I'm going to the question. Estimate the long run co-integration equation. And they're saying copy and paste your E-views result in your answer sheet. So how do we do it? Let me put those ones, those two. I'm having my E-views as well as my stuff here. Yeah. Now, we want to estimate the long run co-integration equation, and we have to paste it here. And if you look here, guys, I know you are seeing that we are given a lot of independent variables, but in this case, let's use what we are given. Let's use what we are given. We are given LRHCE as well as LRM3 as our independent variables, but we have so many. But let's use what we are given here. I'll explain why we do this in practice. But let's use what we are given here. We just want to run this equation. But I know you can see here that guys, can you see that in our data set or here? Let me show you here. Let me go to eViews. Where's my eViews? Here. If you look here closely, the HECE here is not in a real terms, it's nominal. But here, we need it to be in real terms and we log it. If you look at M3, guys, the M3 here is nominal. But here it should be in real terms and we log it. So this is what we should do quickly before we do anything. So I want to start with M3. How do we make M3 real? You go to generate. We want to have RM3, which should be equal to the nominal money supply, which is M3, divided by CPI, multiplied by 100. So you must, if you do this, you have your RM3. Can you see that I have my RM3 there? And on top of that, I have to log it. How do I log it? I go to generate. I want LRM3 is equal to log of what? RM3. Then I close. Are we together there?
Yes.
Yeah. Prof.
Okay. I'll click OK. Then you're looking at, yes.
Can I just ask you why we don't log it originally, like in the beginning, like why we make two separate variables?
I'm saying what we are given, the data we are having, it's nominal. Can you see that? M3, it's nominal terms. But we want it to be in real terms. How do you make?
Yes, so I understand that, but I'm just asking, like, why do we have M3 and then we make it to RM3 and then we go log RM3, like instead of just going from M3 to log RM3, if that makes sense.
Yeah, I'm getting you. What we want to log is RM3, isn't it?
Yes, sir.
But we do not have RM3. So let's create the variable RM3 first and then log it.
Okay, yeah, that makes sense. Thank you.
Thanks. Now we move to HCE. If you look here, we are just given HCE. But what we are looking for is LRHC. But we do not have RHCE. So let's make it real first. So it will be RHCE is equal to log what? Tell me.
HCE.
HCE, right? That's the first thing.
Aren't you supposed to
We want to make it.
No, we have to make it real first.
We have to make it real first.
Yes.
Thank you so much. How to make it real? It's HCE
Divided by CPI.
Divided by CPI multiplied by 100.
Times 100.
Thank you so much for that.
Mm.
Thank you. Remember, today it's a Saturday. Saturdays, they come after Friday. We are human beings, eh? Maybe I drank something on Friday. Okay, it's fine. RHCE is equal to HCE divided by CPI times 100. We have it real first, but we want the logged one. How do we log it? We go to generate. We want to come up with a variable called LRHCE, which is equal to, tell me.
RHCE.
Log.
Log
Log.
HCE.
We start with log.
RHCE.
Right.
Thank you so much.
Yeah.
So we find there. Oh, let's not forget to save our work, please. Let's not forget to save our work. Now I'm here. We are given this equation. Let's do it. The independent, we start with the dependent variable. If views, we'll pick the first, or we'll take the first variable you will click as your dependent variable, right? So in this case, our dependent variable is LRVAT. Let me click on it first. Where is it? Here. Then I have to press my control button on the keyboard. Which one should I pick next? Which one?
LRHCE.
L. Oh, yes. Then the next one?
R.
RM.
R. L. R.
L. Oh, this one, right? Then I let go of the button. I right click. I open as.
Open as a question.
Equation.
As equation.
As a questions.
There. That's what I have. But if I look at these guys, I will just what are they saying? Let's read the question. There's someone who is saying here, am I the only one with no audio? I think she's the only one, eh? Others, you can hear me, right?
Yeah,
Yes,
If it's a set.
we can hear.
Okay. The question is saying, estimate the following long-run coin regression equation. Copy and paste your eViews results window in your answer. Oh, great then. So it's easy. We done there. We don't change anything. It's least squares, right? We just click on OK. There is the eViews results window. They are saying copy it and paste it there. So I'm doing that. I'm copying everything.
And paste it.
Copying and I'm pasting it here. So look, guys, what was making people get zeros in the exam last time? You know, students, sometimes they do these things together. And it's only one person who is running the stuff. Ne? Others are saying, you just run. Myself, I'll just maybe paraphrase here and there. But they forget that eViews will tell us the time. Can you see that? It also tells us the date. But here, the time is important. But the date, obviously, it will be the same date for everyone. On that, because the exam date is the same for everyone, right? But the time you can't, everyone cannot have 1105 serious. Can you see that? So it will be a problem. That's why these days they are saying copy and paste. They're trying to look for those ones who just get the same stuff. Are we together there, guys?
Yes, we are.
Yes, sir.
Yeah.
Yeah.
Yeah, please make sure even your time, you know, the time cannot be the same. It cannot be. Then the other one, they said they were smart. They said one guy was just running the stuff. Then the other guy will just come here where it's 1105. The other guy will write 36. Your students, you will not. So some guy was doing this, coming and changing stuff there. And I said they are clever. It's fine. Let's move on. So please be careful. This time will kill you. Yes.
In the previous classes, I think the professor said it's preferable we start with our constant. Can you just clarify there?
Yeah, it's up to you. You can just copy it as this, or you can change stuff. He is preferring to start with a constant. Why? Because when you are writing your equation here, can you see that it starts with the constant? So sometimes they say copy and paste, or they say put your results here. So it's one and the same thing. You can just go back. I'm going back to estimate. Can you see? I'm on eViews. You can just quickly go back to estimate there. It will give you back your equation. You remove this C here, then you put a C here and space. You start with the C. Can you see that? It's still the same though. So you can, yeah, it's still the same. Sharp. But it's rare to see students having something like this. Yeah, I don't think they will mark you wrong, but you can't have the C there. But still it's fine, but you can't have your C there because you get it by the functional form of this one. Are we together? Yeah.
Yes.
Sharp. So are we fine with this one?
Yes.
Yes.
So let me leave my C where it was. Let me leave, it was there. Mine was there. Let me just leave it there. Mine was there. Still fine. Okay. Let me make my eViews, maximize it. Can you see my eViews clearly?
Yes.
Okay.
Yes.
So the next thing here, guys, is to save this equation. This equation is very important. That's the first important equation. You need the long run equation. We will be using it again and again and again as we go down towards the modeling, the last question. So we need to save this. If we do not save this equation, it means as we move down there and we want to use it, you have to run it again. So we don't have time to be running these things now and again, right? So let's save it. How do we save it? You close it there. Look, I just clicked on close there. It's giving me an option of saying name. I click on name. You can write a name. Some other guys can just say long run equation or whatever, but let's not waste time. Leave it like that. It was EQ01, right? I think so. Yeah, it was equation 01. Just leave it like that. This one, don't name it. You know that your equation 1 is your long run equation. Then you click on OK. Can you see that I have my equation there with the equal sign? Can you see it? Equations, they'll be having that one. But don't forget to save your work. There is an equation there, equation 01. I want to use this equation. I will be using it, right? That's why I'm saving it. Let's minimize this. Let's go to the question. The next question. Oh, what are they saying? Let's read the question. Maybe we are not answering the question. Estimate the following long run co-integration equation. Copy and paste your e-views results. How many marks are you given for that?
2 marks.
Yeah, because you did nothing actually. You just copied stuff from e-views and you're pasting them there. Right? Fine. Now the next one they are saying, evaluate the potential long-run equation. Do the estimated coefficients correspond to your economic theory in terms of sign? So we need to have it, We need to have it here. Oh, the equation is here. Here's the equation. Or I can open it here on e-views. There it is. Let's make it big. There it is. They are saying evaluate this, right? Where's the question? Here. They are saying evaluate the potential. Do estimated coefficients correspond to a priori expectation in terms of sign of the sign? What do you think in terms of the sign? Can you see that the relationship in terms of the sign, the relationship between our, can you see the dependent, you know this, the dependent variable is here, right? This is the dependent variable. The dependent variable versus this one. In terms of the sign of the coefficient here is positive. Can you see that? This dependent variable versus this one in terms of the sign is positive here. Can you see that?
Yeah, there's showing that there's a positive relationship between the two variables.
Yeah, so we are saying there's a positive relationship between VAT collections and what? Household consumption expenditure. Is it making sense? Is it true? To say if household expenditure is increasing, we expect the VAT collections to also increase. Is it making economic sense? Yes.
Yes.
Okay. Okay, so on this one, I'm fine. What about the money supply? Is it true that as money supply is increasing, we also expect the VAT collections to increase? Yes, you said it's true. Why are you saying that?
Because
It's an increase of consumption.
Okay. So you are saying if money supply increases, consumption is also increasing. How do we increase money supply? You are saying when the central bank reduces the repo rate, it's now easier for people to borrow. They can even go borrow more and spend more. Is it what you are saying?
Yes.
Oh, great. You know your economic theory. So let's move on. So if they say evaluate in terms of the signs, we can actually say there is a positive relationship between VAT and both these are independent variables, and is indeed confirming to our what? A priori expectations. You can even put an explanation and you get 2 marks for that.
So for some reason on my table, because I've been doing it on e-views at the same time, so with your table it'll be like 0.74 and for the coefficient, but with mine it's like 74.159. I don't know why it's like that. Do you know? So if we look at the log real HCE.
Others, are you getting, what are you getting, others?
Mine the same as yours.
Yeah, same as mine.
Because this is what I got when I was doing it last week, and this is what I'm getting today. So
Yeah.
I don't know. Maybe you send me a screenshot of what you are getting.
Perhaps you didn't convert it to real properly.
No, I did convert it to real. Like all my values are the exact same in the table. It's just not like 0.74. It's 7.74.1591. So it's just a decimal place. But yeah, I don't know. I'll redo it and then
Yes,
I'll send you a
can you please
message.
redo it and you let us know.
Thank you, sir.
Okay, now moving forward. Where are we? 3. We are now on 3.43. Guys, are you there?
Yes, sir.
Yes.
Okay. Just give me a second. Let me have some water here. I'm coming back. Okay. Let's move on to 3.42. We done. 3.43. Generate the residual series for your long run equation. Name your residual series as follows. Res underscore the first 3 letters of your name. For example, res underscore FAN. Demonstrate how you can use the residual series to test if co-integration exists between variables in the long run. Okay, so here I want to explain something before we do this, right? So may you please listen good. What are we trying to do here? We are trying to test for possible co-integration between variables. But now it's like we want to test if there's a relationship, possible co-integration between X and Y from what I'm having here. These are the residuals or error term, right? And so for you to test for co-integration between Y and X, the first thing that you need, what is the first thing that you need? You need the equation, isn't it? You need to have this equation first, right? Are we together there? You need to have the equation first, which is this part. After getting the equation first, you now use your methods of testing for co-integration. So before you test for co-integration, you need the long run co-integration equation first, which is this one. We're done with this, we're fine with it. Are we together there? Right? Now, how do we test? There are so many ways of testing for co-integration, but let's use the easy one. We know it has its own weaknesses, but let's use it. That's what we are using it actually for ECS4863 by those two guys, Engel and Granger, right? Remember, after testing after testing everything, after testing for stationarity, you are seeing that your variables are integrated of order 1, right? Oh, I'm so sorry. I'm so sorry, guys. I skipped this part. It was, I have to read it. Sorry for that. I have to take you back. This part is very important. I just have to read it. Because you'll be like, huh, where is it coming from? This part. Can you see this part? You can assume that all other variables are non-stationary and are integrated of order 1. In other words, assume that all those other variables we didn't test for stationarity are all of order 1. In other words, they are not stationary. They are stationary after differencing them once. Are we together there? This is very important. Remember, we didn't test for stationarity for all the variables, but they're saying just assume that all are of order 1. But if you have time for practice purposes, you can test even this one for stationarity. You can test this one for stationarity. You can test even those labor, all the variables for stationarity. But we are saying, let's assume that we have tested them and they are all integrated of order 1. Why are we having this assumption? If our variables are not integrated, let me repeat, I know you did this with David. If your variables are not integrated of the same order, you cannot move to co-integration using the Engle-Granger. Remember, we said if you have your y is equal to alpha plus beta x plus the error term or the residual, right? Remember, we said here, if this one is integrated of order 1, and this one is integrated of order 1, and if this one is also integrated of order 1, if you regress this one on this one, you are more likely to get spurious results, regression, right? That's what we said. But there's a chance, there's actually, there is, I'm saying, if y is of order 1, x is of order 1, there's a chance that your results will be spurious. But before you look for that, test for co-integration. If there is co-integration, if they are co-integrated, it means you can go ahead and come up with meaningful results at the end of the day. So what is it that we want to do? We are saying, let's use the residuals method to test for co-integration. Let's use the residuals method to test for co-integration. And if the residuals, which is the U, after using the residuals method, if these residuals are integrated of order 0, after using the technique that we're going to use, you can conclude that y and x are co-integrated. If we are going to use our method that we are going to use, and at the end of the day, we see that our residuals are integrated of order 0, we have to conclude that y and x are indeed co-integrated. By the way, if something is written as I, Sianda, if we are having I 0, what's the meaning of it? If we say U is integrated of order 0, what's the meaning of it? What's the meaning of it, Evelyn? What's the meaning of it, Dan? We are saying is
That's the
stationary.
difference.
Yeah, is stationary in levels. Before you difference it, in levels, you test, if you test for stationarity in levels, it means it's stationary in levels. There's no need for you to move to first difference, right? This is what we want to do today here, actually. So we are on, where are we? We are here. We are on 3. Let's do it so that we move on. Please follow so that it will be easy for all of us. We are here. So these guys are saying, you know what? Make residual series, or let me rewrite it. Please, you have to be patient. We're going to cruise, but for now, I want you to understand. Just be patient. You know, if you know why you are doing things, you are going to get it easy, even when you are doing it. You will not forget the steps. I don't want you to use your notes, to use your books or those notes from lecturers in the exam when you're doing this. These things should be done without you looking at anything. You know that I'm now doing this part, I do it like this, because you know the theory behind it, right? So what are we saying here? We want to check if y and x are co-integrated. We want to use a method by Engo and Granger called the residuals series, the residuals method, right? What is this method all about? These guys are saying, look at the residuals, make residual series. Make residual series, that's the first thing. In other words, I want to come up with u is equal to what? You know, I'm not good in mathematics, so please forgive me if I make mistakes. Am I correct here? Making u subject to the formula, is it what you get? Is it? If we don't consider this, is it what we get?
Yes, sir.
Yes.
That's it, right? So in other words, we are saying, I want you to listen to my language here. I'm saying, we want to check if there's a relationship between y and x. Do you think the intercept matters here? Or it's just wasting our time here? Do you think the intercept matters? No. We can even write it as y is equal to beta x, right? We want to see if there's a relationship between y and x. If you look at my model here, can you see that this one has no intercept? Can you see that? Can you see that, guys? There's no intercept. Yeah.
Yes.
The intercept, we can even leave it. It did not tell us anything to do with the relation between y and x. We can just leave it in this case, right? So there's no intercept, or we don't need trend and intercept in our model. We're not going to need intercept. So our model is actually none. Can you see that? It's none. It's none, right? Now, we are saying plus what? Plus u. We want to make u subject to the formula. It will be u is equal to y minus beta x. What am I doing here? I'm making residual series. I'm processing residual series. I'm processing the residual series. Residual series. I'm processing, I'm making them, right? So these guys, Engo and Granger, they are saying, from the residual series you are having, in other words, this u you are getting, test it for stationarity, right? If it's stationary in level, conclude that y and x are co-integrated. Are we together there? What's the process? The process is to make residual series. After making residual series, test them for stationarity. If they are stationary in level, and your model should be none, because we are seeing that there's no intercept there. If they are stationary, conclude that y and x are co-integrated. Are we together there? Are we together?
Yes.
Okay, let's do it in. I want to go to e-views. Listen to my steps that I'm saying. But that's what we want to tell e-views. I'm repeating the steps. Yes, we are having an equation. And it's the equation that we saved, if you remember. I said we have to save this equation. So from the equation, that's where you get your residual series. That's where you will be able to make your u subject to the formula. U is equal to y minus bx. Are we together? From that equation. Are we together? So the equation is there already in e-views. That from that equation, we want to make u subject to the formula. In other words, we want to make residual series of that equation. When we have the residual series, we need to name our residual series. The name we are going to give to our residual series is this one. Call it res underscore. In this case, because my name is Love More, my given name will just given these names. It will be LOV, right? Res LOV. For you, it will be what? Res what?
SIZ.
You see, so this is what I want to do. So the steps, we go to the equation in e-views, we make residual series, we save our series. When we're saving our series, we have to name them, right? How do we name them? We were told, please, we need the first 3 letters of your name. Repeating for the last time, we go to the equation, we make residual series. We name them. After naming them, we test for stationarity. If the residual series that we have named and tested for stationarity is stationary, our conclusion should be the relationship between the variables. There is actually co-integration between variables. Great. So let's go and do that in e-views. You said you have understood, so I'm going to e-views. So let's do it together. Let's do it together. What are we doing? Let me close this. Tell me, what are we doing? We want to test for co-integration. The first thing, you go to the equation, right? Which is this one. Are we together? Can you hear me? We open we open the equation.
The long line equation.
After opening the equation, what should we do? We want to make the residual series. We want to make the residual series. Let me write it so that you understand. We have opened the equation. Now we want to have u is equal to. Are we together? We want to have u is equal to something, right? That one. That's what we want. We want to make residual series. So we want to process. We want to process. So I'm here. Can you see that? It's written proc for process. We process. What is it that you want to process? You can process a lot, but we want to process residual series.
Yes.
Right? I'm clicking on residual series. Sorry, let me remove this. We want to make residual series. Leave it on ordinary. But what about the name? What about the name? Your lecturer said there, right? Res underscore, because it's me.
Love, yeah.
Yes.
Then okay.
That's LOV. Then okay. We're done. Can you see that this is the residual series that we have made? And it's always good to check, what are you having? These are residuals. From where? From the equation, right? What was the dependent variable? This was the dependent variable. These are the residual series. And what is the name of the residual series? Res LOV. You need to first click on the equation, you open it, you process. What are you processing? You want to make residual series, right? Now, if we go back to our e-views, like here, let me close these ones. You can see that I have that residual. Can you see that? Res LOV. I'm now having res LOV.
Sorry, so can you please redo those steps just with the residual again from the equation?
Okay. The first thing, we open the equation.
Then you go to process.
We go to process. What are we trying to process?
Make a residual series.
When we are there, you can just click OK and you move. But there's an instruction from your lecturers. They want to check if you know what you are doing. They want to check if you guys are not copying each other as well. So what are we instructed to do here?
Res
On the name.
underscore
Res
underscore
underscore
LOV for your name.
for my name. Then okay. Did you get it, my dear?
Yes, sir. Thank you.
Sharp. So we're done here. Hey, you know, let me save my work. I don't want to start all over. Keep on saving your work. So now I have this new variable called res LOV. And if I'm to ask you guys, but don't answer it, I'll answer it. According to the angle Granger, how do you test for co-integration? According to the angle Granger, you need to have the long run equation first. From the long run equation, make residual series. When you make your residual series, you are almost there. From those residual series, test for stationarity. Test for stationarity of the residual series that you have made. If it's stationary in level and you have included none in your model, you should conclude that the variables are indeed co-integrated. Repeating for the last time, according to Angle Granger, when you're testing for co-integration, open your equation, process, make residual series, rename your residual series if you want. In this case, we're instructed to do that. It's now called res LOV. This is mine. Yours will be different from mine, the name. But everything in there will be the same. But only the name. Res LOV. Test for stationarity of that res LOV. If it's stationary in level and they've included none in your model, conclude that there is co-integration between variables. Now, this is the res LOV. I'm double clicking it, right? I'm going to view. I'm testing for stationarity. Should I test introduce in first difference? No, in level. Are we together? Should I include that intercept? No.
No. Yes.
No. Just none, right?
Yes.
Remember, I actually wrote it down and I said, no, if you're having something like this, if you're giving something like this, right? And you want to check for co-integration, this one, we don't need it. There's no need for us to have this intercept. It will not help us in checking for co-integration. That's why we are having none here. Right? Fine. So if you have this one, you click on, you click OK. This is what I have. This is what I have. If you look at what I'm having here, tell me, is it stationary or not?
Stationary.
How many stars?
Stationary.
3 stars.
3 stars.
Stars.
So what's your conclusion?
That
Oh, intricate.
Co-integration.
There is
There's a
co-integration.
co-integration between the variables.
Yes, yes, that's how we do it. So how do we present it now? Here. What was this? Oh, those are the answers I wanted. So here, this is what I'm having. What is the hypothesis testing for co-integration? Obvious, the now hypothesis, we are saying there is no co-integration. The alternative hypothesis, we are saying there is co-integration. What is the rule? We reject the now hypothesis if the p-value is what? If the p-value is less than 0.05. Oh, let's just use our rule of thumb, the ADF, right? Let's just use our ADF. We said if ADF is less than the test crit, right? What do? You conclude that the variable is stationary. Sorry, I'm mixing up things here. Before we come to this one, let's finish this side. So here, I think you need a table. Let me quickly put it up for everyone to see. Let me put a table here and I conclude. You need it. These guys are not putting things for you this year, but I have it somewhere. Where is it?
Will we lose marks if we don't mention the p-value?
That one. Okay, we will get there. Just a second. Let me bring something. We are going back to 2019. Imagine, hey, and doing these things.
Before Corona.
Yeah, before Corona, we've been doing these things since 2017. Imagine. I want to copy something and put it there. Well, these days, these guys are not giving you tables. Long back, very few people were doing honors and they were trying to make us like it. But, so this is what I'm having here. You can just try to put a table, right? Maybe in this case, I can add what? Everything's fine. But mine is not called res n, it's called res LOV, right? It's called res LOV. Guys, are you seeing the Word document and you are seeing it, right?
Yes.
Okay, great. We need this. Just put this it will be easy to present your results. So the model is res. Was it a model? No, this is not the model. Let me add something. Sorry for that. What is it? Want to insert a column up to the left. Yeah. This is the variable, right? This is the variable. The model is none, isn't it? We use none, right? Then the leg length, it's 7. What is the tau or the ADF? This is the ADF. We're just trying to present our model in such a way that we will not miss some stuff. The ADF, I'm copying this ADF, I'm putting it here. Oh, this is the ADF, I'm copying it. I'm putting it here. How many stars? 1, 2, 3, right? The p-value, I'm copying it here, or you can leave it. I'm putting it here. You can present it like this part, right? Let me also save my work here. So the question is saying, how come we're not seeing the question? Well, the question is up there. Generate the residual series for your long run equation. Name your residual series as follows. Res underscore the first 3 letters of your name. res, something like that. Demonstrate how you can use the residual series to test for co-integration. To test if co-integration exists between the variables. I'm now demonstrating it. I generated the residuals called res LOV. I tested for stationarity. Can you see that? I tested for stationarity, the model was none. I got the leg 7, the ADF this, which is showing that it's stationary at 1% level of significance. So in this case, I can safely say, I can say, I reject the H0 because my p-value, we can look at the p-value, we can look at this one. The results indicate that the variable is statistically significant at 1%, which was 3 stars, which means that we reject the null hypothesis of no co-integration. In other words, we are saying there is co-integration between variables. Are we together there?
Yes.
Yes.
So please make sure you put this table. You have this table. Show them your results. Don't just go straight away. You are using e-views. You are looking at your e-views. Then you just come and conclude and say, yes, the results indicate the variables. They want to also see those results. Are we together? Or some guys can do this. People are different. Others can just copy this part, right? This part, instead of putting a table, they paste that part here, you see? Because we are having this part, you are showing the lecturer that you know that I'm looking at this part, I'm looking at the probability or that one. In this case, variables are indeed co-integrated. So it's up to you, but myself, I prefer to use that table. You can copy your results from there, you paste them here, or you can use the table. It's up to you. Are we together there?
Yes.
Oh, sharp. Let's move on. Let's move on. Where are we? Oh, so we're done with 3.4. Can you see that? We're done with 3.4. Let us try to do 3.5. I think we'll finish this. Let's quickly do it. Guys, who is having questions on what we've covered so far? But I think if you follow these videos, you will be in a position to answer that assignment. I think if you're having any challenges, you then text me, send me an email, a WhatsApp message, and I will see. You can even take pictures and say, this is what I'm getting. When I do ABCD, I'm getting this. Then we try to see how we can assist you, right? So let's move on. Where are we now? Construct. Oh, hey, the good thing I want to explain the, oh, not with you guys, sorry. Look, short run component of your model. When we're testing for co-integration, we're actually using the long run. I explained that, right? I explained that.
Yeah, you did.
Yeah.
You did.
And I even put that y, and we saw that the first part of y, the variable was actually changing. Like if you, let's try to use, for example, GDP in 2019. The figure of 2019 is different from the figure. Let's go back to 2010. For example, the figure for 2010 is different from the figure for 2011, different from 2012, different from 2013, right? But as you move maybe for the last 4 years, like 2019, 2020, 2021, 2022, maybe the figure is the same. You know that you actually what? You've reached the steady state. That's the long run equilibrium. It's fair and fine, we're done with that. But what about the short run? We should also check our model. What will be happening in the short run? Remember, what we want is, in the short run, there could be some deviations from the equilibrium. If there's a shock, how soon will our model go back to the steady values, to the long run equilibrium? If there's a shock, will it take us ages to go back to equilibrium? Will we move? Are we going to move fast to the equilibrium or not? So let's look about the short run. Let's talk about the short run. And when I'm talking about the short run, we are making use of the ECM. Why is the error correction model important? Why is it important? It is very important because we can actually check whether the model is capable to adjust to its long run equilibrium after facing some shock or not. Or it can actually help us check whether the variables have significant relationships in the short run. We are seeing that in the long run, the relationships, the variables are having significant relationships. What about in the short run? Are they having that? Let's tie long run and short run together. So the short run is also important. That's why we are bringing in the error correction model. Let's say there's a shock. What will correct us to go there? So I like these guys, Engo and Granger. They make our life easier. So they are also moving to the ECM. We are done with the co-integration. Now we are moving to the ECM. What are they saying about the ECM? Let me write it down for you guys to see what I'm trying to say for ECM, so that we'll see if we'll be in a better position to answer this one. Can I ask you something here? If I write a model like this, maybe I put the coefficient, the constant. The question to you now, is this model a short run model or a long run model? What do you think?
Long run?
Short run.
Oh, short run.
It's a short run. Why are you saying it's a short run? Because in the long run.
It's a constant.
Sorry? Oh, I didn't get you. I'm saying, remember we said in the long run, the change in Y or the change in X is equal to what? Do you have changes? It's equal to 0, right? When you're in the long run.
Yes.
They're equal to 0, right?
Yes.
But in the short run, these changes, they're equal to some number, right? They're not equal to 0. So that's why you are seeing, if you're doing a long run equation, you are doing it in levels, not in differences. Remember, to say change in Y, for example, to say change in YT, it means what? It means the difference between YT, meaning Y of this current period, minus Y of the previous what? Period, right? This is what is called difference, isn't it? That's the difference we have been doing, the DD that we've been using. This is what we were doing, right? This is the difference. These are difference equations. This is the difference, right? This, I know you know this. This is the change in YT. So when you are talking about the differences or the change in YT, you are actually want to see the marginal effects here. So this is actually a short run model. You are right there. This is a short run model. So when we are trying to write our short run models, you will see it will be having the D's. Are you seeing the D's here? Guys?
Yes, we do.
That's the short run. That's why you're having the D's there. So whenever you are writing your error correction model, you will see that the D's will be there. But the long run, it won't be having the D's. Are we together?
Yes. Yes.
So this is what we want to do. for today, and we'll finish. Let's just run. Let's just estimate the short run co-integration equation. We copy our answer, we paste it there. But this short run, we are given. I will explain more on the legs. How do you get these legs? You know, economics is actually it's a science, and it's also in art econometrics. You are also going to be doing some modeling, playing around with some stuff here. If things are not well, you see us changing the legs to increasing the legs on some or decreasing. We'll do that. But this one, obvious, you are seeing here, in my case, this will be res what? LOV.
Love.
Yes. Then T legged ones. T minus 1. This one. Okay, great. Let's do it and we finish. Because I know you have a class now, so let's quickly do it. So let me use this one and my e-views. Let's quickly do it and we go. This one and my e-views. Okay, so how do we do it? We just run an equation. You can even, I know David showed you, you can even like type them. You go to quick here, you go to quick, you estimate, quick estimate. It's like you are typing things down. Like the first one is D. The first one is here. Let me show you where the first one is. The first one is here. You can actually type it. What is it? It's what? It's D, you open bracket, LRVAT, right? It's in this period. So we just close. You space, you move on to the next like that, but it will take time. We don't want this. Let's not use this method. We should just be clever here and be quick. We are having LRVAT. I'll click it here because I have it already. Where is it? LR there. We are also having LRHCE. Where is it? There. We are having LRHYD. Oh, unfortunately, we also have in this case, we need to make it real and we log it. So we are not gonna do it. You do it when you get home. Then there's lab, there's inflation. But I can quickly do it, man. Because we don't have RHYD, which is equal to HYD divided by CPI times 100. Right? Oh, sorry. Times 100. Oh my God. RHYD is equal to HYD divided by CPI times 100. Then you have to log it. Log RHYD is equal to log RHYD. Where is it? There. Right. So you also have to click on it. What else do we have? We have the lab. The lab is here. What else do we have? We have the INF. INF is there. What else do we have? We have the res LOV. This one, res LOV. You release the control button, you right click, you open as equation. You click it. When you get inside, it's now easier. You just have to play around with what's there, the D. So you put the D there, you open bracket, you go, you close. Don't worry, we'll do this first. Next week we meet and we finish the assignment. Then the DRHEYD is still in this period, just T, we close. We move on to the next one, which is DLab. Oh, this one is D. This one is this current period. We move on to the next one, which is DLab. DLab, but the DLab is legged. How many times? It's legged twice here. The DLab I'm looking at is this one. It's legged twice, T minus 2. But I don't have to write my T here. It will not pick it. If it will not pick T, it will just pick minus 2. This means you're legging 2. You're you're going back twice. If it's -1, you're going back once. So you don't put the T, you just put bracket there, -2, you close for this one and the other one. You go to INF, it's not even difference. Remember, it was stationary in levels, but it's
Legged twice.
Then lastly, you don't difference the res. I'll explain why. And this one is always legged once. I'll explain why it's always legged once. So if you do like this, it means you'll be done. You click on your OK. Can you see that? So this is what we are having. This is what you are going to copy, but we will redo it, don't worry. This is what you are going to copy and you paste it. I don't know, where is it now? There's somewhere where they say it, then the question, paste, I don't have it here, but we'll paste it on that question and you'll be done. So thank you so much for joining me today. Others they should join is it what? Finn. Thank you so much for joining me. I will push what I'm gonna do. What I'm only going to share with you are these e-views output. Definitely, I will do this and I'll share with you, but not the theoretical part of it. So I'll finish and I'll share with you this document, but you get it maybe on Sunday with the e-views output. So that when you're doing your stuff, you'll be comparing with what I'm also having here. If I make mistakes, you will tell me. If you make mistakes, you can correct. Thank you so much. Others they are about to start another lesson. Thank you so much for joining me.
Thanks, sir.
Thank you, sir.
Thank you.
Thank you.
Bye.
Thanks so much.